suppose a large number of nuclei are de-exciting and this is my target. Okay, as a result of some nuclear reaction, a lot of nuclei are produced in the nuclear reaction inside the target, and they are all de-exciting. These lines that you can see, they are de-excitations by charged particle emission or gamma ray or whatever. Now for the time being, let us assume that they are gamma rays. So if say this gamma ray exits the target and we detect it in a detector, this is what I am talking about. Next, some other gamma ray, say from here, it also can come and enter the detector. Now in this case you see they are two different gammas. This is gamma 1, this is gamma 2. Now if they both enter at the same time, what will happen? The energy carried by this gamma 1 E1 and the energy carried by these two gamma 2 E2, if they are detected at the same time, that is detected within same time interval, or this is known as coincidence window, then what will happen is that instead of two signals of different amplitudes corresponding to E1 and E2, we will get the added up signal. So we will get a bigger signal having amplitude of E1 plus E2, okay, instead of the separate ones. Now this coincidence where we are getting gamma rays from two different nuclei, you can say this is not a true coincidence. This is, you can say, a sort of spurious or random coincidence. Then what is a true coincidence? A true coincidence will be basically like this. Again, I am considering the target. Then from the target, again a large number of nuclei are present, and from them some are de-exciting as a result of the nuclear reaction. Now during the de-excitation, say for example this particular nucleus, one gamma ray exits and another gamma ray also exits. Now if this gamma is detected in say detector 1 and the another gamma ray is say detected in detector 2, okay, this is what is happening. Now this is true coincidence that we are going to talk about. So gamma 1 with energy E1, this is gamma 2 with energy E2. Now the thing is that they are genuine coincidence events. Genuine coincidence events or true coincidence events. So how do we record this? Now this is being recorded in detector 1, this is being recorded in detector 2. Then how am I going to correlate them? You understand? This is the issue. So the way out of this is the following. We, from the detector, there are two, remember, signals from each of them. One corresponds to the energy spectroscopy, another corresponding to timing spectroscopy. The energy spectroscopy channel we have already talked about. What are the components of the energy spectroscopy? We have got, after the preamplifier, we have got amplifier, right? Preamplifier, amplifier, then we have got a discriminator, say a single channel analyzer or a multi-channel analyzer, and then counter, scaler or timer. This is more or less the energy spectroscopic channel. Now this here, the amplification and SCA, this takes a longer time. lots of electronics is involved, the processing time is large. However, for the timing signal, identical signals are coming, this part will be very fast because we need immediate timing information from them. And here again, we after the preamplifier we have got a timing amplifier and then a TSCA. So basically what we are going to do now, the first thing we are going to do is look at the difference in the energy channel. Here the signal is analog, again in the amplifier the signal is analog, in the SCA or MCA the signal becomes digital. Okay, now in the timing part, just after the preamplifier, this signal when it comes out, okay, now inside the detector there is preamplifier, so this part is already inside the detector. Now instead of this amplifier, what we will be doing, the first part is we will be considering the digitization of the signal. So basically if from the two, বুঝতে পারছো, basically from the two detectors, detector 1 and D2, say first we have got two different energy signals, their heights are different corresponding to the incident energy, right? Now also they are coming at slightly different timings. So now what we are going to do, first we are going to digitize this signal, make them digital, and then suppose this are the timing axis, they are coming at the different time. Now you see we have to define some coincidence window where we can say that okay, they are coincidence enough, and this is what we define in the circuit. So if this is our coincidence window and you see these two, they are well within this coincidence window, so in this way this signal 1 and this signal 2 will be coincidence. This is what I was telling last day. Now how is this implemented? So basically the implementation goes like this. So suppose I have got two signals like this, okay, one here, another here. What I do is I always add them up. Now as a result of the addition, here I will get, you see, one like this and another like this. However, so they are not coincidence events. Now again, suppose this time consider two genuine coincident events like this. So if we add them up, then what will happen is the following. You will get a signal like this. Okay, now we will put a threshold over here and observe if we get any signal above this certain voltage threshold. The presence means that there is coincidence between them. So this is how we implement the coincidence. Okay, so this is what I have discussed last day. Fine. And then regarding the circuit, remember what I did is the following. Basic coincidence circuit. Again we have got detector 1, D1, and then detector 2, D2. Fine. So from there we have got the, now I am considering only the timing part. Fine. So I have got a timing SCA discriminator, timing discriminator for each of them, timing discriminator. You can say as if that. Now again there is another component which goes to the energy channel. I am not showing this over here, corresponding energy channel, I am not showing this. Fine. Now in the timing channel, you see, even though I am taking, suppose I am taking identical detectors and identical timing discriminators, but still they have got different somewhat electronics involved. So the same event, if they are coincidence, they might come at a different time in each of them because of the difference in electronics, right? So we need to match them up. Now these are two genuinely coincident events. So how do I make them coincidence? So I introduce delay. Remember the speed of light, c is equal to 3 into 10 to the power 8 meter per second, or this is just 30 centimeter per nanosecond. So if I introduce a cable of length say 90 centimeter, then in this particular here channel, suppose I introduce a delay, basically I am introducing a cable of length 90 centimeter, then what will happen? Then basically this signal will get delayed by how much? 90 centimeter, 30 centimeter per nanosecond, so it gets delayed by 3 nanosecond. And if I see in the CRO, now you see both of them are coincidence. You understand? So this is how we artificially introduced a delay to make genuine coincidence. Now how do I do this? So basically I can use a separate electronic component known as pulsar, where the same signal is fed to both the detectors. So they are of course coincidence because they correspond to the same signal. Now if there is any change, then I can introduce the delay, and thus I can calibrating. So this is basically calibrating the circuit for coincidence by using pulsar. This is yet another electronic component. I am not showing this over here, but this is the basic idea. And then after that, and so after this I will then put the two signals, just a second, then I will put the two signals in a logic gate. Okay, a logic gate, and then later analysis will be done. Now since they are coincidence, I will get a signal from the logic gate, and if they are not, I will not get a signal. Now, this is how the things work in basic coincidence circuit. So the basic idea C is the following, that from the same detector, okay, I get energy information, I can get a timing information. This goes to a separate electronics circuit, then again the timing goes to a separate electronic circuit. Now this takes a lot of time to process, so this will be a slower arm. The signal when it comes here, it takes longer time, whereas the signal when exiting the timing electronics part, it will come faster, but they are both the same signal. So what do? I introduce a delay so that the signal from both the arms, if this is the signal corresponding to the energy, then at the same time a signal corresponding to the timing also comes. This is the timing axis. So this is the reason for introducing delay. Remember, the energy arm will always be slower and this timing arm will be faster. The reason for using faster electronics is that so that we can do the analysis, the timing analysis much faster, and for getting information about the energy in a peak, that is for doing the pulse height analysis, we need processing time, and that's why this energy electronics is slower than the timing electronics. But nevertheless, if we introduce the delay, then I can finally make the two signals coincident, and then I can do the analysis for the later part. Okay, so this is the basic idea.